This is the notes for section 5.3 and 5.5. 5.5 has to do more with links, and that's what we're looking at here. The same application goes to angles, and that's why we're going to go ahead and do the notes together. And I'll talk about that here in a minute. The first thing that we have is the triangle inequalities theorem. It says the sum, so we're adding the two segments together, of the lengths of any two sides of a triangle must be greater than the length of the third. So, for example, if we have AB, and when we add BC, it has to be bigger than the third AC. The reason that I want to do this section at the same time is that if we know that AC is the longest side, we also should know that B is the longest angle, the biggest angle. And that's all that section 5.3 says, is that if you know that an angle is bigger, you know that the side is bigger. So, vice versa. If we know that the angle is small, or the smallest, it means that the opposite side would be the smallest. All right, and then I have that BC plus AC is equal to the third side AB. And then the last one, AC plus a BAB is bigger than the third that's left over, CB. Okay, so this is for the lengths. Section 1.3 is for the angles. So determine whether the length given should be sides of a triangle. And what happens is that if you have a triangle that the other two sides are not longer than the third, it actually won't close and won't create a triangle. So you need the other two sides to be bigger than the third. So let's check it. Is 8 plus 10 greater than 12? Yes. How about 8 plus 12? Is that going to be bigger than 10? Yes. And then the sides that are left is 10 plus 12. Is that bigger than, what's it left? 8. Yes. That means that this can be a triangle. Prove why that is true with one inequality. So why are we talking about just one inequality if you have to check all three sides? Because if one side doesn't work, so 1 plus 2, is that bigger than 3? No. Then it doesn't work. That's enough to say that it cannot be a triangle. Just one. One fails, it cannot be a triangle. Okay, so 4 plus 5, is that bigger than 10? No. That's enough to say that it cannot be a triangle. Just one. All right, let's check these. 14 plus 15, is that bigger than 11? Yes. 14 plus 11, is that bigger than 15? And then the last one that we have to check is 15 plus 11. Is that bigger than 14? Yes. So this one can be a triangle. Yes. I think that that is enough explanation. I don't feel like we have to do any more, so we won't. The next little section. On this next section, what's happening is that you're missing a side length. And you have to set up an inequality to give possible answers. To determine the range of values of the third side of the triangle, set two inequalities. So we always take the smallest side with the x and set it, is that going to be bigger than 9, the side that's missing? And then what you try to do is get the other two measurements that you have and set that equal to or greater than, it has to be greater than x. Okay. You're going to add the two smallest sides together and the two given sides together, is in essence what they're telling you. We're going to solve for x, so minus 4 to both sides. X is greater than 5. And then 4 plus 9 is 13. And that has to be greater than x. Now we have to write a compound inequality, and it always goes this way, that x is in the middle. These inequalities are always facing this way. So if you happen to have a highlighter, I would highlight this if I were you, because this always will end up this way. The smallest number will always end up in the left, the biggest number on the right, and there's your compound inequality. What that compound inequality means is that that length has to be between 5 and 13. All right, let's do some practice. Determine the range of the values for the third side of the triangle with the given side. So we have 1, 2, we're missing the third. We're just going to get the smallest with the x and set that greater than the third side, which is 10. And then the other one would be the two given sides, 8 plus 10. And that's given greater than x. We're going to subtract 8 from both sides. X is greater than 2. We're going to add these two together. 18 is greater than x. And then we have to set our inequality. It always has the x in the middle, these symbols facing that way. Smallest number to the left, the biggest to the right. So again, what that means is that that third side can be anywhere from 2 to 18 to be possible third side. Let's skip this one just to have enough space. Let's do this one. We're going to get the smallest one with the x, so 4 plus x is greater than the third. Sorry, the third side's x because we don't know it. The third side is 5. The other inequality is the two given numbers, so 4 plus 5 is greater than x, the third side that we don't know the value of. We're going to subtract 4 from both sides. X is greater than 1. 4 plus 5 is 9. That's greater than x. And then the inequality always looks the same, where you have the smallest number on the left and the biggest one on the right. Again, what that means is that the values of x are anywhere between 1 and 9. I'm going to skip this one and go to this one. The smallest number with the x. So 8 plus x is greater than the third. Sorry, that x is the third side that we don't know the length of. 9 is greater than 9. So then when we solve for x, x is greater than 1. The other inequality that we have to check is the given numbers. So 8 plus 9 has to be bigger than x. That 17 is bigger than x. We write the inequality the same way. 1 to 17. Is there any questions? No? All right, let's go ahead and start our homework.